Right. The concept is a binary search tree. So first of all, the complete theory about binary search tree. So what is that binary search tree? Just a representation of data in the tree structure. The tree structure means what? Let's say is a parent and these are the childs. These are the childs. Like again, these are the childs for this and these are the childs for this. So level by level is a we are representing the information in the form of a tree. But here in binary search tree, every node, nothing but every parent node, let's say this is called parent, is at most, so maximum of having two children only. Children. Here it is. In the binary search tree, every parent has at most two childs. At most two childs. Let's say, for example, this is also binary search tree. Reason is there is no left node, so null. There is no right node, is a null. Is a null. Next. Suppose we just connect like this. Only that left node is there. So right node is not there. So is a null. And for this again, left and right are null nodes. Is a null nodes. And for example here, the two nodes are there. Two nodes. And it is also valid. And remaining for these two and for these two are null nodes. Null, 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 and null. Here it is. A tree with n nodes. Let's say here one node is there. One node. Here it is a two null nodes are there. A tree with two nodes having three null nodes. A tree with three nodes having four null nodes. So nothing but if the tree with n nodes having n plus 1 null nodes. Having n plus 1 null nodes. So that is what a binary search tree. Now, how can we insert the data and how can we delete the data and how can we display the data? Only these three we need to understand. Here it is. For example, if we go with insertion is a simple one. Simple one is a highest value goes right to parent and least value goes left to parent. Goes left to parent. Let's say taking the example of suppose is a 50. First I'm inserting the value is a 50. So if there is no node, there is no node. So it will be connected as a root node because it's a first node. The first node is always a root node. A root node. And now let's say I just want to insert the value is a 30 or 20. First it will compare with the parent node and the value is a least value than this. So is connected to the left side. 20 is connected to the left side. For example, I want to connect a 70. So compare with this 50. 70 is a highest value, so that is connected to right side. Next one, for example, here it is a 40. Now observe, first is comparing with the root. Compared to root is the least value. Then come to left, compare to this. Compared to this node, it's the highest value, so that it is connected to the right side. Right. Is connected to right. So this is how that elements connected to the list. Every time compare with the parent node. If the data is lesser than that parent data, it goes left. If it is higher than the parent data, it goes right. So this is the way of inserting the elements into the BST. The next one, yeah.
Representation is done like linkage.
Same.
That.
Yes, linked list only. I'll explain. Now, that is in the coding concept, I'll explain. Here it is.
Sure.
Now, if it is a displaying the information, display. Whenever we are displaying the data, here it is, in three ways we are displaying the information. So what are those? So first one, we can say that Inorder traversal, Inorder traversal, Preorder traversal, Preorder traversal, and Postorder traversal. Postorder traversal. In three ways we can represent. Let's say I'm taking that parent P, left child and right child, taking. It's a parent, is a left child and right child. Let's say this is the tree. This is the tree. In case if it is Inorder traversal, it goes like this. Left child, parent, and then right child. First one, left child will come, then parent will come, then right child will come. We need to display in this format. In case if it is a pre-order traversal, in this case, here it is. First, the parent will come. After parent, we need to display the left child. After left child, we are displaying the right child. First, we display parent, and then left, and then right. Next one is a post-order traversal. Post-order traversal. In this post-order traversal, right. So first of all, we need to specify, right? We need to specify the left child. Then we need to specify the right child, and then we need to specify the parent. The first left child, and then right child, and then parent. In this one, only Inorder will give the sorted order. When you are using, whenever display the elements in Inorder, simply here, it is a sorted order. The most easiest way of explaining Inorder traversal, preorder traversal, and postorder traversal with one simple example. First, I am taking the nodes.
Okay. I thought maybe I will take the screenshot.
No, I'll explain. I'll give, don't worry. Everything is a documented. I'll give. And here, now, suppose I am taking this one here, right? let's say I'm taking a list and some values we are taking of 50, 30, 20, 40, 40 is a 70, 60, and 80. Suppose we are taking like this. In case if it is in order traversal, first child, left child. So it will check left is there or not. It will check left is there or not. Yes. After left child is a parent and then right child. Now for this left is completed. Left child, parent and then right child. In the simple way, how can we represent means what? Just if you place the things like this, if you place the things like this, then what are the edges connected is a like this. If you just traverse through borders, what all the things connected, simply you can represent that in order traversal. Here, so first 20 connected, next 30, next 40, next root is a 50, then in the right side, left child is a 60, 70, and then 80. 20, 30, 40, 50, 60, 70, 80. So this is what how it is connected. Now, in case if it is a pre-order traversal, just we need to give first parent, then left child, and then right child, and then right child. So same way, the connection 50, 30, 20, once left completed, parent and left, then right. Here it is the same, parent, left child, and then followed by the right child. So 50, 30, 20, 40, 70, 60, 80. So this is what pre-order traversal is. The same way, in cases of post-order traversal, just we need to place like this. Just to tell easily the traversal. So the first one is a left child, left. After left child is a right child. After right child is a parent. Same. First is a left child, then is a right child, then is a parent. Finally, that last parent. So this is like how we are connecting in the post-order traversal. So once you insert the data, how can we display the information means what? In three ways we can display the information. In order, pre-order, post-order. In here, just what is the node representation means what? Same like a double linked list only. In double linked list, we have a call it as a left link and right link. Here we can call it as a left child and right child. Here it is just node representation. Like this. So this is, let's say, for example, address is 1,000. It's a root node is 1,000. Root node is 1,000, which contains a 50, like which contains a 30 and which contains a 70 consider. And this is a left child and this is a right child. This contains 2,000 and this contains a 3,000. 3,000 is connected like this. And here it is a total how many nodes are there? Null nodes, null, 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 null. Remaining all the nodes are null nodes. So this is like a representation, like how we are writing the code and how we connect the data actually in the background is a node representation. Just like a double linked list only. There we can call it as left link and right link. Here we can call it as a left child and right child. That is. Now, That last one is a deletion part. Here, a deletion again fall into three cases. Three cases. So what are the three cases? The first one, deleting a node with no child. No child. Second one, deleting a node with a single child. Third one, deleting a node with two childs. Deleting a node with no child, deleting a node with a single child, deleting a node with no child. Three cases are there. The first one is deleting a node with no child. Let's say, suppose here I'm taking like this. This is the parent node and this is the child node. First here it is a 50 and 70 is there. 70 and here it is a 50 and 30 is there. Suppose consider 50 and 30 is there. Now our target is this one. This is the target that we are going to delete. Is a target that we are going to delete. And this is the parent. Oh my God. So once again I'm writing, don't worry. Here it is. As a node with a single node child, we are going to delete. Suppose here I'm taking 2, right? It's like a 50 and 70, and it's like a 50 and 30. This is our target node. We are going to delete. And this is a parent node. Parent. For every node, we need to consider the parent node also. Reason is, let's say if you are deleting this one, how you delete? By disconnecting this link. By disconnecting this link. Okay. So first you need to confirm that, okay, I'm going to delete this node. How can you decide that? The node with no children, node left and right should be empty, null. So first we need to confirm that if the target to left is null as well as target to right is also null. Then we decide that, oh, okay, I'm deleting that node with no children. Again, the node is connected to parent to right side or the node is connected to parent to left side. If the target is connected to parent to right side, then make parent to right equal to null. No. Else parent to left equal to null. Parent to left equal to null. This is how we delete the node. First we have to check. Here, in that case, again, two subcases are there like this. You are deleting a node with no children, but the node is connected to either parent to left side chance is there or parent to right side chance is there. So where we need to connect is important. And now, let's say for example, I want to delete a node with a single child. First, how many chances? For example, is a 1. Next, is a 2. Is a 3. And is a 4. Here, first one we connect like this. Second one we connect like this. Third one we connect like this. Fourth one we connect like this. Let's say, for example, 50, 60, 70. And here it is like a 50, 70, 60, 60. And this is like a 50, a 40, a 30. And it is like a 50, 30, and 40. Suppose these are now our target is, this is our target. Target 60, 70, 40, 30, our target. Our target. So here two things we need to consider. What are the things? The node is having left child, right child, or left child. And node is connected to parent to right side or parent to left side. See, consider this is the target. For this target, right is there. First and last, you see.
Correct.
But this target is connected to parent to left side, I mean right side. And this target is connected to parent to which side? Left side.
Left.
So target to right, you need to connect to parent to right. Got it? So then make it target to right equal to null. Here parent to right is equal to target to right. Then target to right is equal to null. Then two connections will lose. This one is what? Target to left is there, but it is connected to parent to right. So target to left, you need to connect it to parent to right. To the parent to right, you need to connect what? Target to left. Make the target to left equal to null. Target to left is connected to parent to right is connection, so it stop pointing. Then we need to free this, so we need to disconnect this. Target to left is a null. Now, the target to left is connected to parent to left. Here, parent to left is equal to target to left. And then target to left equal to null.
No.
Then these two connections we lost. This one. And then target to right is connected to parent to left. Because here target to right child is there, but the target is a parent to left. So parent to left equal to target to right. Then target to right equals to null. So here it is. The node with a single child again fall into four sub cases. These are the things. Now, the final one is a node with two children. Node with the two children means what? First of all, I'm just creating with a number of examples. Let's say number of we are taking, suppose is a 50 and is a 30 and is a 10. Let's say 5 and 15. Let's say 40, 35 and 45. Is a 70. Is a 60, 90. And here it is like a 55. and is a 65, is a 75, is a 95. Suppose consider. Now here it is, I am going to delete a node with two children. Whenever you are going to delete a node with two children, any node you just consider, and you need to take a consider. I'm going to delete this root node directly. Consider. This is our target, a node with two children. Here, when you delete this one, which one become root node? This one or this one is a fail. Even if it is a root node, let's say consider 30 is a root node. So then C is a 40 still connected to left side. Whenever you delete a node with the two children, you need to consider what is the highest value in the left subtree or what is the least value in the right subtree. You need to consider what is the highest value in left subtree, and what is the, sorry, what is the least value in right subtree. You need to consider. Any one you choose, not both. You need to code for either left side one or right side one. Let's say is the right side one I'm considering, this one. So first of all, you need to replace this value with a 55. And then you need to delete this node. That is the case. Then only that a tree will be structured as well as a tree follows the same set of rules. In place of that 50, either you can put 45 or you can put 55.
Okay.
Apart from that, any value if you put, then it won't works because it will violate the rules of the BST. That is. So you need to find out. Suppose if you are writing that, let's say, okay, this is the right. This is the target to right. Let's say consider target to right. And using the while loop, you keep on searching until you go down. Finally, you need to search what is the least value. So then you need to place that value into target root. Then you need to free. Means what? This is a parent, na? Just parent to make it a. So this is how to delete a node with the two children. Like this is completely theory about the BST.